All right, students, so some of you wanted me to make a video on arc measure and central angles. So here we go. Here's, I believe that's Pizza Steve, and I guess he forms a central angle, right? So a central angle has its vertex at the center of the circle. So every slice of pizza, this angle formed by that slice is a central angle. And so what that means is the measure of this arc, so the amount of turn. And we're not talking about the length of the arc, it's just how much turn is involved, so the degree measure is equal to its central angle. So we're going to look at a couple of problems related to this. So here's the first one. If this is a central angle here, 165 degrees, and this should look familiar, it should look like the handout we gave you in class. If this is 165 degrees, just the amount of turn of this central angle is also going to equal 165 degrees. So the central angle, the arc measure, equals its central angle. So it has nothing again to do with the length of this arc. It's just the amount of turn. So let's look at a more complicated example. So if this angle here, from here to here, is 95 degrees, then that's a central angle. Its vertex is at the center of the circle. Then this arc here also is 95 degrees. So an arc is just a part of a circle. And so a circle is 360 degrees. So this part happens to be 95 degrees. And so I know this is a diameter that was drawn in as a diameter, one straight line segment. So this has to be 180 degrees. So what's left? 85 degrees. So they have to add up to 360. These two angles here are supplementary angles. They form a linear pair. And this is a semicircle, right? So that's 180 degrees. So the other part of this problem related to this angle here, this angle C. So we need to figure that out. So one thing you have to remember about circle problems is these are all radii of the circle, and all radii are congruent. So you're going to see a lot of isosceles triangles. So this triangle here that I've highlighted in orange is isosceles. So that means that we have two congruent base angles. So this has to be equal to this angle. This angle here and this angle here have to be the same. So the measure of angle B plus the measure of angle C plus the measure of angle C over here has to equal 180 by the angle sum theorem. If we know this one's 85, we can solve for the measure of angle C. 2 of the measure of angle C equals 95, so that's actually related to our exterior angle theorem that we learned way back when. So this angle on the outside of the triangle equals its two remote interior angles. If we divide both sides by 2, then the measure of angle C is 47.5 degrees. Let's take a look at this a little further now. Let's look at this angle here. And we've learned these are inscribed angles, so its angle vertex is on the circle, not in the center. It's actually on the circle. And if we draw that out, notice that its intercepted arc, this is the arc that it's kind of grabbing, is 95 degrees. This is 47.5 degrees. So an inscribed angle is actually half its intercepted arc measure. So that's why this actually is true, is because radii of a circle form, they're congruent and they form these isosceles triangles, which creates this phenomenon here. So a central angle is equal to its arc measure. An inscribed angle is half its arc measure. So let's take this one step further and look at this problem. So if we know an entire circle is 360 degrees, and they told us that this arc here is 66, so the remaining part of the circle has to be 294 degrees. But remember, congruent chords, these are chords, intercept congruent arcs, so we have 6 congruent arcs, 6 congruent chords and 6 congruent arcs. So all of these arcs have to be 49 degrees. So that means that this central angle here has to also be 49 degrees. So we need to now find angle Y, but this is just like the last problem we just looked at. We have an isosceles triangle. So this angle Y has to be 65.5 degrees. This leaves us with this crazy angle up here, angle X. But remember, an inscribed angle with its vertex on the circle equals half its intercepted arc. But what is this intercepted arc? It is 49 times 5. 1, 2, 3, 4, 5, which is 245. And then if we just divide that by 2, because it's half of that, it's 122.5 degrees. So I hope this helps. Please let me know if you have any questions, and I'll talk to you later.